Could you introduce yourself and what field you're coming from, your background?
So my name is Greta Panova. I'm a professor in mathematics at the University of Southern California. I do algebraic combinatorics mostly, but I also do research in connections with computational complexity theory, probability, statistical mechanics, and sometimes I also work in molecular biology, which is completely separate endeavor.
What brought you to the Frontier Math Symposium?
I also am a problem writer and I'm on the editorial board right now for the Putnam Mathematical Competition. So I'm involved in creating problems. And before there was any AI, I'm always very curious about problems, what's doable, what's not, whether it's for humans or AI or any of that. So of course I would join.
I'm wondering, how did you approach writing the problem for the symposium? And that process, how would it be similar or different to coming up with hard questions for students, like your work with the Putnam?
So for the symposium, it took several iterations because Elliot wanted the problems not to be guessable. And then I realized that yeah, I can come up with something hard that's basically only I know how to do. So there are some things like that. It's just not a very mainstream thing. Eventually I found some case which I could solve, but was out of reach of anyone without having the ideas that it involves. And And then of course, we tested it with the current AI systems. Even if you tell it basically what to do, what papers to look, whatever, it just has no idea how to proceed.
Do you think a research mathematician or a graduate student would be able to do it? And if so, how long would it take them?
It is possible, but they would need to get all the hints somehow. If they're given the problem from scratch, it's not a canonical thing. It involves several steps, several non-trivial steps. So there are very few people who would know how to approach it. That's something I was doing when I was doing my PhD actually. So it took me quite some time to figure that out. It took me some more time to figure out the current problem. So
Would you say it's much harder than the hardest problems on the hardest tests, that being the Putnam?
oh yeah.
Uh, yeah.
Yes, because it also involves theoretical constructions that are a graduate material and all these other things. So it's not an elementary problem.
How long do you expect AIs to struggle with it? Or, yeah, how long will they take to solve it?
Initially I had a forecast about 1 to 2 years. So now I'm not so sure. So I've spent a lot more time with the ChatGPT Pro version and testing problems for Putnam and so on. And it's not so good at extrapolating, and it's not that clear how well and in what direction it will develop, to be honest. And it might take longer than 2 years. I mean, of course, it depends on how the community and OpenAI and all these other companies involved in training models, how they will continue to pursue this and how serious they would be for theoretical math.
How good are the current frontier models you've been interacting with at math questions?
Well, these models have some abilities that humans don't. I mean, they have a huge database. They can search very quickly. They can mix and match. They can compute. They can run Python code. They can do all sorts of things that for us, it would take some time. At the same time, right now, what they seem to be doing is they're piecing together different arguments from the literature if they are more mainstream. So maybe they appear in several textbooks and exercises and things like that. It will know how to apply. but something that is very special and maybe appears only in one paper or it's pretty obscure, it wouldn't know even to look at it. And of course, also the logic is not properly built in yet, so it's doing logical errors. It can try to prove an inequality, it would reverse the arrow, the direction at some point arbitrarily. So it's just piecing together things that seem to look right. And I mean, that's how it was probably trained also. And sometimes it is right.
So I think O for mini hide does not search, but then O3 is able to just Google things. Have you seen like a difference between those? I'm guessing the search models would be better at finding some very specific results.
So one thing that ChatGPT tends to do is give fake references. So for references, I've used Copilot more often. That one can actually find papers and summarize information correctly, at least some superficial extent. But then other features are missing. So, and of course, one should take it with a grain of salt. You know, if it's searching the web, so there was this joke among programmers. I told you to take it from Stack Overflow. Well, yes, I did. You should have taken it from the answers, not from the question. So sometimes somebody posts some code saying, "Where's the error in this one?" And it may not realize that it's getting the wrong thing.
If the AI or like one of the reasoning models was your student, is there any advice you could give it or you would give it?
So the reasoning models act quite differently from a student. So the thing that is missing is really some connection with the logic base. So proof verification system so that it makes sure that all the arguments are correct. Maybe not undergraduate students, but graduate students certainly know how to write a proof and they will notice immediately when there is a gap. And right now, the AI models don't see the gaps, as I said, so they can invent some steps. It's still pretty rudimentary.
Do you use AI models in your research or teaching at all for math?
I try. So, unfortunately, the problems I cannot solve, the AI also cannot solve so far. So it hasn't been very helpful in that respect, but it is helpful in generating code, testing hypotheses. It can even run that code itself. So let's say find me some examples, compute the first values, things like that. It can all also, if you give it a paper, it could at least understand some of it, summarize it. If there is an algorithm described in the paper, it may actually try to apply it and run it and then get you some output from that algorithm. Again, so it's not clear how correct it is. Of course, if the algorithm is not described very well, it will also not take this into account and give you errors. But things like that, so more mechanical things it can do, and this is really helpful. So but again, one should be very careful what it's giving you because it sounds very convincing. It gives you something that looks like an answer, and somewhere in the middle of it, something might be switched, and it make the whole thing completely wrong.
Looking into the future, do you expect the sort of role of a mathematician to shift? Or like, will it be pretty much the same?
It really depends on how complicated a task you give it and how advanced mathematics you want it to do. I'm not yet sure how we're gonna build in the error checking and the logic. I can't give predictions, but it's developing like humans in some sense. So so I do expect it to be able to do what humans can with a lot more computing power than we have.
Another question I have, like, is there a specific time when an AI model surprised you, something related to math, whether in a good or a not so good way, whether it was great or disappointing?
So the first time I started using the AI was was a few months ago. But the story is I wrote up a proof for something that we call combinatorial interpretation. So the coefficient of some sequence have a positive combinatorial formula in the sense that they are counting some things. And what came out of this proof was something horrendous, counting some things, but it's like some trees with some labels on the leaves, and then some kind of global condition on all the leaves, and it just not your friend. So I sent it to some people who were looking at these things, and they're like, "What is this thing? I don't understand anything. Can you give us an example?" I mean, I was myself really frustrated with the whole thing, so I couldn't. I didn't want to spend too much more time on this, and just for the sake of having an example, I gave the paper that I wrote. I gave it to ChatGPT, and I asked, "Can you run the algorithm from this paper, compute the example for whatever values?" The first time it ran it, it gave me something wrong. Then I realized I forgot to specify something in the write-up. But once I wrote it, then it actually gave something completely correct. So that part surprised me positively in some sense. Other parts that that surprised me maybe negatively. It's not really a surprise, but you ask it a question and it gives you something completely wrong. It's like one really unprepared but ambitious student comes and says, I want an A. Look here, I did this. That's not quite correct, but like, can I have some more points? You know, that part I wish it wasn't doing this. It was. I mean, maybe it shouldn't be acting like a human that much. I mean, it's not. That's not the value for these models. And I guess the third thing is that it does seem sometimes it does seem surprisingly good. I mean, sometimes it gives the correct answer with the wrong reason, but I have no idea where the answer came from. It's almost like Ramanujan, was coming up with this identities for huge infinite sums over partitions, and it wasn't even clear how how he came up or how it was derived.
Do you think it's possibly quite good at the sort of creative or intuitive kind of thinking? I guess this surprises me because what I've heard a lot so far is, it can find an example or write some code, do something concrete, like look through, it has access to a bunch of data, so it can like pull from that. But then it seems like you're mentioning the intuitive creative leaps to me feel like a very different flavor of like mathematical thinking.
Correct. That's true. But I mean, in some sense, this is the part of our own thinking process, that reasoning process that we don't quite understand, which is when we solve a problem that it's not some straightforward algorithm we need to apply, and we have some creative idea. So we identify it as creative, but in reality, probably in the back of our minds, this we are also searching searching the space of various mathematical objects and identities or whatever, and somehow matching what we have from two different fields, which which is probably the most creative part of mathematics. It's like seeing seeing some object and realizing it can correspond to some other object where you already have some tools available and apply this. And it seems that those AI systems are also doing something like that. That's how they become creative. It's not that mysterious, it's just that we don't see the search process that led to that.
Do you think it's conceivable, given that the AI seems to already be doing sort of both the creative thinking and math and getting the data and gathering the information? Is it conceivable that it will be sort of as capable as a current research mathematician in some amount of time? And you can tell me how long you expect that to be. Do you think AIs could, in principle, ever get as good? And in that case, what would happen to mathematicians, and how would that their role shift?
So in the early times, the AI is gonna get better and better, and it will help us probably. So it will do proofs of simple statements, maybe do various calculations, give us examples to lead the way. So all these little things that we spend time on when we do research, those will be easier and faster. So in the short run, it's probably gonna be good. Okay, with one little caveat, because this will also lead people to produce more papers with, with questionable content, and this will flood the space and journals and everything. So I'm not sure that that will be that good. The human aspect in the whole thing is that we still have a big picture in mind that the AI doesn't seem to have. And the human part in the process is going to be the selection or the editorial part, where we figure out what's valuable, what's not, in what direction to go, which problems to solve, things like that. But in the long run, it is conceivable that the AI will become better than any human at anything. So I have a claim that if the AI actually can do math on the level of a math professor, then it will be able to do anything else that is just intellectual work that doesn't require some kind of dexterity menial work. And then the whole humanity has a problem in some sense, because then suddenly all jobs will disappear. The hope is that others will be created, but I'm not so sure. I mean, I'm not that positive it's gonna be all good. And of course, there are alignment problems. So whether the AI will become autonomous at some point and start doing things against our own good, then there are other problems like what is actually good. I mean, it might be good for one person, maybe bad for another. I mean, people are excited in the short run, but if you start extrapolating, you will soon realize that a few years from now, who knows? Maybe we can't really imagine. It's not gonna be like in the movie Terminator. It's gonna be something much more benign looking.
Is there one thing that worries you most?
So for mathematics specifically, the most concerning part is that if at some point AI starts to solve actual open problems, maybe Riemann hypothesis or some other millennium problem, without serious human intervention, and that would lead to a collapse of the whole field somehow.
Be on a somewhat brighter note, Is there any advice you would give to either the math community or new math students in relation to it?
To the math community, I think we should all get involved in what's going on in these benchmarking processes, in steering the AI in the right direction to aid us rather than distort the field in some sense. For grad students, even though there may be an AI system which can solve all the simple problems in the textbook or whatever, we should still be able to do this ourselves because at some point this AI system may not be there, and the less we understand how things work around us, the more vulnerable we are. So we should not just rely on the AI to do things for us, even how to compute an integral, even though Mathematica already could do this for most of the integrals, like already 20 years ago. We should still know how to do these things, and then we should all, I think, and try to understand how these large language models actually work, what makes them go in certain directions. And this is both for AI safety, but also for general alignment usefulness. So this is still going to require mathematics. So we should continue to learn mathematics. It just maybe the end game is not gonna be what used to be now. Maybe we'll have to solve different types of problems.
You mentioned the importance of being involved, thinking about these tools, and also the benchmarking process. And I guess coming back to frontier math, what do you see as the value of this effort? Why do we want to come up with these hard problems in general? How do you see that?
In all areas, we like to have some benchmarks to basically test how capable the tools that we developed are. Even in pure math research, you're trying to find some bounds. When you do one step, you have one bound, and you have to do another step, another bound, and all these steps are also benchmarks in some sense. So you're trying to improve something, you're trying to beat it. So it is important to know what the AI systems can do or not, whether in maths or in any other field. And it is important to interpret the results of what they can do correctly. So in that sense, it's mathematicians who should decide whether the AI can do math. And so they should be providing those problems and ways to assess the answers to those problems. So right now with Frontier Math, because there are not so many actual mathematicians involved in the assessment process, the benchmarks are made so that the answer is some huge, complicated. It is some large number that cannot be guessed nor just computed with brute force. So when it gets to that number, you know it did something right. So that's doesn't unfortunately necessarily mean that it's actually solved the problem correctly, because in many fields the hard part is to prove something, even though you kind of obvious. It may look obvious or intuitively clear, but to find the right arguments to dress it in and derive it is really the hard part, like for example in analysis. And so we should be more involved in the assessment part, because we don't want to get to a point where, let's say, next AI model gets the right numerical answers to all these frontier math questions that we submitted, and then somebody higher up says, "Oh, well, then math is done." So AI can do math. You just stop all funding for math. Stop doing math. Go do something else. That would be horrible.
And do you expect the problems from the symposium as a whole to like stand up against AIs for pretty long? How big is that fear that, they'll just solve everything pretty soon?
I don't know all the problems, and I don't know in other fields. It's a complicated question because sometimes somebody may think that a problem is hard because it requires knowing many theories and interpreting something in various ways, but then the AI is doing some pattern matching immediately and it just puts it together and solves it. So there may be problems like that. So they would be easy to solve soon. I mean, there are problems which require some computation that you cannot, a human would not be able to do by hand, but if you actually plug it in into some equation, it will come out immediately. It is hard for a human, but not for a computer. At least some part of those problems, at least a few ones that I've seen, should survive for a while, just because they require many non-trivial steps that are not available in the literature. And in some sense, if only a few people know how to do this, it's gonna take a while for the AI to start learning from that. And in fact, that's actually one aspect in which humans are still better. So humans can learn from just one. We can extrapolate from very little data, and the way the models are trained, they require a lot of data to learn the same thing. So they're not so efficient. Somehow humans seem to be more efficient, and we don't exactly know how our brains work to say that, but yeah. And so problems that require some very, very specific knowledge and ideas that are not readily available in the literature will take a while. So whether it is 1 year, 2 years, I don't know, five.
Yeah, makes sense.
Yeah.
What will it take an AI to surprise you in the future, say? Because you're quite familiar with, what they're capable of now, and what would need to happen for you to go, "Wow, that's actual math right there."
Well, I mean, if I see an argument that was not a modification of something that was already there, like something that we would interpret as honestly creative, something that is not available in the literature, something completely on its own, like it did in the when it was training for Go, the AlphaGo. So it was learning from humans and human moves, and then it was extrapolated. That at some point it just figured out a move that nobody would ever do. It's like it was a new move, and it won. It started winning. So if it does something like that in math, we haven't seen any of that yet. But if it does something like that, that would be that would be scary and surprising.
And I guess a bit more broadly, to what degree do you expect AIs to reshape math?
It may as well be that certain fields may even die. I'm not exactly sure, but certain fields may disappear, and it will create other fields. So it's not a lose-lose situation. It will change the problems that we care about or that we think are significant. Just as a simple example, just maybe 30, 40 years ago, people were publishing papers with binomial identities. And eventually the technology developed. You can even use some software to try and guess these identities. So this is not considered serious math anymore for most part. And the same thing will happen when AI comes.
on a scale from 0 to 10, where 0 is the level of pocket calculator and 10 is mathematicians just going obsolete, how much do you expect AI to reshape math? Um,
I would say 8.
and then similar related to that, how much will AI reshape the world? Where 0 is again a pocket calculator and 10 is sort of at least as much as the Industrial Revolution.
Maybe 9.
If you could choose whether to stop AI progress, so that would be a 0, or sort of accelerate as fast as possible, where would you land? Yes.
Yeah, I mean, that one is hard to answer because I don't think it's any of us has the power to actually stop it. So it's there are so many companies, the technology is available. There's just no way you can stop people from developing large language models further, even though the European Union is trying to do this right now. It's just impossible. So, but I wouldn't want to accelerate it. So maybe the answer would be 4 or 5, just because we need to. I mean, there's something that's going to develop no matter what, so we should at least have some control on how it develops. And we should try to exert control. And if it develops too fast, then we will lose control because humans themselves don't develop so fast. I mean, we cannot keep up.
If you had to put a number, so maybe in years or months, how long it'll be until an AI system solves your problem. Yeah. Do you have a rough estimate on that?
I would say a year and a half, 2. I mean, again, so it depends on how much effort is put in in lean, and there is some work required to be done from mathematicians in the process. So if you just keep training large language models, I'm not sure it will succeed. So it will need something else.
Do you think there's a way a model could be made better at math with the help of mathematicians, or if there is some special fine tuning or something that could be done to make it better at that specific kind of thinking?
Yeah, definitely. So I mean, I've not trained models myself, but from what I understand, if it's not trained by mathematicians, it just is not gonna be that much better. So it needs mathematicians to figure out what to feed it, how to evaluate the answers, how in what directions to steer the model and things like that. So it cannot just randomly learn math. I don't think it's that good.
From Math Overflow.
Yeah,
That's
the
the
from the
questions.
questions. Yeah. We are doing this after sometime after the symposium, so we have new information, but there was a Scientific American article and also Financial Times article that came about the FrontierMath Symposium. And in the Scientific American article, it's somehow took a quote from Ken Ono that ChatGPT is as good as a graduate student, as a PhD, as a good PhD student, or something like to that effect. So first of all, this is wrong. So of course, Ken Ono was really amazed that it solved one of the problems that he created, but overall, most of our opinions are that it's not nearly as good. And I mean, of course, it depends on the graduate student, but certainly the good graduate students are much better than that. And in general, we should be careful with statements like this. AI is not nearly close to solving mathematics, the hard parts of mathematics. Nobody should be making such insinuations. Many mathematicians are excited from the possibilities, but if you extrapolate far ahead, things become dangerous in some sense. As a community, we should think about this and we should try to be involved in the process of AI development and see where things go.